We'll get back to section 3.6 here. We're talking about complex zeros. Now, all I've done so far is talk about what a complex number is. A complex number is a number of the form a plus b times I, where a and b are the real parts and I is the imaginary part, okay? And so we looked at some examples, where we're adding, subtracting, multiplying, dividing complex numbers. Let's take a look at these problems next. We're going to find all the zeros. Okay, so f of x equals 4x squared minus 5x plus 2. That's a quadratic. And if I set that equal to 0, that's not going to factor nicely, no matter what I try there. And so I'll use the quadratic formula. Okay, so x is equal to the opposite of b, that's 5, plus or minus the square root of b squared, negative 5 squared is 25, minus 4 times a is 4, times c is 2. And this is all over 2a, 2 times 4 would be 8 in the denominator. Okay, 25 minus 32 is negative 7. Okay, so I got 5 plus or minus the square root of negative 7 all over 8. Now, at this point, I can know that I've got complex solutions, okay? Because the square root of negative 7, that's not a real number. The square root of negative 7 simplifies to be I root 7. Okay, we saw that right here, right? So my answer then would be 5 plus or minus I root 7 all over 8. You always have two answers when you're solving a quadratic equation. Okay, so it would be 5 plus I root 7 all over 8, and then 5 minus I root 7 all over 8. Okay. How about this one next? So what if I have g of x equals 3x cubed minus x squared plus 27x minus 9. And I want us to find the zeros for g. Okay. By the way, in the directions here, I want us to find all the zeros. Okay. So you want to look and see, do they want you to find all the real zeros or all the zeros? Those are two different questions, right? So finding all the zeros means that, hey, we're going to have complex numbers possibly, in the answer. Okay. Now, if I set this equal to 0 and I solve the equation, so I don't have a common factor. However, factoring by grouping is going to be the way to go. Okay. So if I let the first two terms be one group and then the last two terms be a second group, what's going to come out of group 1 would be x squared. That's in common with those terms. And that's going to leave me with 3x minus 1. And so I'm going to need another 3x minus 1 coming from group 2. And if I bring a 9 out from those two terms, I'll have 3x minus 1. Okay, so 3x minus 1 is in common in these two groups. Let's go ahead and factor that out of the whole thing. The leftover from group 1 is x squared. The leftover from group 2 is plus 9. That's equal to 0. Okay, so then set each of those equal to 0. 3x plus 1 equals 0 means that x is 1/3. And x squared plus 9 equals 0 means that x squared is negative 9. When I take the square root of both sides, the square root of negative 9 would be 3i. And of course, I need a plus minus there whenever I take the square root of both sides in an equation. So I'm going to have plus or minus 3i as the other two zeros. So all in all, I got 3 zeros. That makes total sense because I got a degree 3 polynomial. I could know before I did anything that I'm going to have 3 answers. Okay, so they're 1/3, 3i, and negative 3i. Now let me ask you this question. Would I want to solve this problem by using the techniques in the last section? Okay, so in the last section, we were given a polynomial and we wanted to find the zeros. And like would I want to guess and check my answers? That would be brutal, right? So in other words, like we saw this problem here, where once you have a 0, then you can divide and get the remaining zeros. Okay, I can't really do that here. I mean, unless I think of 1/3 or 3i or negative 3i, I can't get started with the problem, right? So the way that we did this problem, that's the best way to do the problem, okay? And, so the point of that is to say, think about the things that you've already learned before this class, okay? It's like factoring. Here I'm using factoring by grouping. That's something that I should have learned before. And then, this stuff that I'm showing you right here, think of this as a plan B option. If factoring doesn't work, then okay, the next thing that I'm thinking of is guessing and checking. Okay. We also have the conjugate zeros theorem. So the conjugate zeros theorem says if a plus b times I is a 0 of a polynomial function, then its complex conjugate, a minus b times I, is also a 0. That will always happen. Okay? So, just because 3i is a 0, there's no coincidence that negative 3i is a 0 also. It had to be that way. It had to be that way. Because 3i is the conjugate of negative 3i. Okay, so they're both zeros. So, like in earlier we were doing finding zeros of polynomials where they give you a k value. If they ever give you a k value where it's a complex number, in a way, they're telling you 2 answers. And you haven't even started the problem yet. You already know 2 answers. If you know the conjugate zeros theorem. Okay? So if they wanted you to find the zeros of a polynomial and, 6i was a 0, well, I can already know that negative 6i is also going to be a 0. Okay? And I haven't even started the problem yet. Okay? Let's try this one next. So how about f of x equals x cubed minus 10x squared plus 29x? X is in common to all 3 of these terms. Okay, so I can factor that out. That would leave me with x squared minus 10x plus 29 equals 0. And so if I set each of these equal to 0, I have x equals 0. That's one answer. Okay, and then I have to solve x squared minus 10x plus 29 equals 0. That's not going to factor nicely. So I would use the quadratic formula next. Okay, x is equal to the opposite of b is 10 plus or minus the square root of b squared negative 10 squared is 100 minus 4 times a is 1 times c is 29, and this is all over 2a, 2 times 1 is 2. Okay, 100 minus 4 times 29 is 116. 100 minus 116, that'd be negative 16. And the square root of negative 16, that's an imaginary number, right? That'd be 4i. We had seen that earlier with this problem. Okay, so I'm looking at 10 plus or minus 4i divided by 2. 2 is in common to these 2 terms up top, so if I factor a 2 out and cancel it with the 1 down under, 2 times 5 is 10, 2 times 2i would be 4i. So my answer is going to be 5 plus or minus 2i. Again, I have 2 answers here, so 5 plus 2i and 5 minus 2i. Now I can know that I'm going to have 3 answers, before I did this this problem, if I'm familiar with the fundamental theorem of algebra. Okay, so I just need to look at the degree, right? I get a degree 3 polynomial, I'm going to have 3 answers. Okay, 0, 5 plus 2i, and 5 minus 2i. Now there's no coincidence that 5 plus 2i and 5 minus 2i are both zeros. It had to be that way because of the conjugate zeros theorem. 5 minus 2i is the conjugate of 5 plus 2i. So they're both going to be zeros. Okay? Let's take a look at, we'll do one more problem here in this section. So what if I had the function f of x equals x cubed plus 6x squared plus 6x plus 5? And I want us to find the zeros for f. Well, I can know that there's going to be 3 answers. Okay? So I got a degree 3 polynomial. Now, factoring isn't going to work. Factor by grouping is not going to work, no matter what I establish as the groups. So I need to begin by guessing and checking. And to help the guessing and checking choices there, I'm going to use the rational zeros theorem. We saw that in section 3.5. Okay. Okay, the p-values are all the factors of the last coefficient, which for us is a 5. The q-values are all the factors of the first coefficient, which for us is a 1. Okay, so what are all the factors of 5? 1 and negative 1 go into any number, so I'll say plus and minus 1, and then 5 goes into 5, and negative 5 goes into 5. So plus and minus 5, those would be the other factors. Okay, and then the factors of 1 are just 1 and negative 1 for the q-values. So the possible rational zeros of f are all the numbers of the form p over q. So plus and minus 1 over plus and minus 1, that's plus or minus 1. Plus or minus 1 divided by plus or minus 5, that's plus or minus 5. Okay? And so it makes sense, that if the number is a fraction, it's going to be one of these 4 numbers listed. Okay, so it makes sense to just guess these, numbers by plugging them in and see if I get a 0. Okay? If I'm plugging in 3, I'm wasting my time, right? Because 3 did not come up there. Okay? So let's go ahead and check these. If I plug in 1 plus 6 plus 6 plus 5 is 18. That's not a 0, right? If I plug in negative 1, I get 4 in return, so that's no good. If I plug in 5 into that, I was getting 310. Okay, so that's not 0. But if I plug in negative 5, and for x, I'm getting 0 left over. Okay, so negative 5 is an answer. And that means that x minus a negative 5 or x plus 5 is a factor of f. So I can continue this problem by dividing, use synthetic division. If I take f of x and divide that by x plus 5, okay, I'm dividing by a binomial, something with 2 terms. Negative 5 is the 0 of the denominator. So negative 5 creates 0 in the denominator. And the top row, I got a 1 in front of x cubed, a 6 in front of x squared, a 6 in front of x, and a 5 at the end. And I'm all set up to divide. Now my remainder should be 0. Okay, let's check that. So bring down the 1. 1 times negative 5 is negative 5. 6 plus negative 5 is 1. 1 times negative 5 is negative 5. 6 plus negative 5 is 1. 1 times negative 5 is negative 5. 5 plus negative 5 is 0. That looks good. I expected that, right? But we're more interested in what's to the left of this. So when we divide x cubed plus 6x squared plus 6x plus 5 over x plus 5, as we did, we get we get x squared plus x plus 1. Okay? And let me take this equation now and multiply both sides of it by x plus 5. So x cubed plus 6x squared plus 6x plus 5, that's equal to x plus 5 times x squared plus x plus 1. Now that's what I'm calling f of x. Right? And the idea is to try to factor f of x so that we can get the zeros. Well, you can see that we've already started to do that. So x plus 5 equals 0. That means that x is negative 5. Now that's a number that I found by guessing and checking. Okay, there's gonna be two more answers to this though, right? Because I got a degree 3 polynomial, And to get the other two answers, I need to use the quadratic formula to solve x squared plus x plus 1 equals 0. Okay, well, let's do that. So the opposite of b would be -1 plus or minus the square root of b squared, 1 squared is 1, minus 4 times a is 1, times c is 1. Okay, and this is all over 2a. 2 times 1 is 2 in the denominator. 1 minus 4 is -3, and the square root of -3, that would be an imaginary number. That's going to be I root 3. Okay, so the rest of my answer here is going to be -1 plus or minus I root 3 all over 2. Okay, so I've got three answers. They're -5, -1 plus I root 3 all over 2, and then -1 minus I root 3 over 2. And again, just to verify the conjugate zeros theorem here. So -1 plus I root 3 over 2 is the conjugate of -1 minus I root 3 all over 2. Okay, so those both are going to be zeros. Okay, and now we use the conjugate zeros theorem to get that. Now, I'm also using the rational zeros theorem to find a zero to help me begin the problem. Okay, so notice how all three of these numbers are not listed. Okay, that's because these two numbers here are complex numbers. You're not going to have a complex number listed if you're using the rational zeros theorem, right? It's only going to be all the fractions. Okay, so I guess the point of me saying that is because I don't want you to just guess and check your answers, to find this. Like I was doing that here to help me get 1, 0, and then once I get 1, 0, I can then continue the problem by dividing, right? Like I don't want to just do all these problems by guessing and checking. That would be a waste of time. And how do I know that these numbers are not zeros? Like I could guess and check and find nothing, you use the method that we had talked about earlier here to get the remaining zeros. All right, the homework in section 3.6 is on page 230 there, so you should be able to have a go at those problems there when you get a chance. And we'll stop the video right there.